Hello everybody, good afternoon, and hope all of you are doing well. Let me take exercise 9.3 class 9 geometry. Okay, circles chapter. Now before going to 9.3 exercise, I would like to make certain things clear, like some basics. Like for example, I had already explained it earlier. Now you know this is called as angle in a circle, and this is called as angle in a minor segment, and this is called as a major segment. Segment means chord and the arc. Angle in a major circle, angle in a major arc, angle in a major segment, angle in a minor segment. And these angles, see this way I'm writing so many like this. I had told you earlier it comes like a M. See, it comes like a M like this. So, and remember, both the bases of the line should be touching the chord. It can't be like this. Okay, it can't be like this somewhere else like this. It can't be like this. Okay, it has to touch here. Then we can call it as angles in the same segment. And remember, angles in the same segment are all equal. You can draw how many ever you want. All these angles will be equal provided they touch the circumference. Even in the minor segment also, see, you can draw so many angles and all the angles are equal. So this is angles in the same segment. Then we come to the another one. See, this is the diameter, because this is a chord which passes through the center, longest chord, and angle in a semicircle is always equal to 90 degrees. Then another thing which you have to come to know is angle in the center and angle at the circumference. Now this is angle at the center, this angle is circumference. This angle A is always double of B. A is equal to twice of B. Then we see the other one, that is, if I join 4 points in a circle. Now this quadrilateral is called as a cyclic quadrilateral, and opposite angles of a cyclic quadrilateral are 180 degrees. Opposite angles of a cyclic quadrilateral are 180. They should be touching the circle. Now if I draw here one angle like this, this becomes angle at the center, this becomes angle at the circumference. Now suppose this is 120, then this angle will be 60 degrees. Now this and this you can interconnect because they are opposite angles of a cyclic quadrilateral. If this is 60, then this will be 120, because both of this is 60, this will be 120, and both of them will be supplementary, that is 180. OA CQ means opposite angles of a cyclic quadrilateral. Please don't write like this, I am writing it just to save my time. Opposite angles of a cyclic quadrilateral. Okay, now coming to the exercise. Now let me start with the first question. Very simple question. Here they have given A, B, C are 3 points here, and O is the center of the circle. D is another point on the circle here. D is a point, and angle AOB is given as 60 degrees. BOC is given as 30 degrees. They have asked you to find ADC. Very simple. This is angle at the center. So we'll write angle AOC is equal to 60 plus 30, 60 plus 30, which is equal to 90. Correct? So this full thing becomes 90. And angle ADC. Angle ADC is equal to half of angle AO. ADC is half of angle AOC. ADC is half of angle AOC because of the theorem. Angle subtended at the center is double the angle at the circumference. Okay, I'm writing a short statement. So angle ADC here we have to find out. Now this is how much here? 90. This is half, or in other words, this angle is double of this angle. AOC is double of ADC, or in other way, how can we say? ADC is half of AOC. So angle ADC is equal to half of 90, that is equal to 45 degrees. Okay. Next question, continue with it. A chord of a circle is equal to the radius. So BC is the chord and it is equal to the radius. Radius is BO and OC. So I'll write immediately here given chord means BC, is equal to radii. Radii means OB and OB and OC. Okay. So therefore, this triangle, all the three sides are equal, means you understand that it is equilateral triangle. Then find the angle subtended by the chord at the minor arc and also at the major arc. This you have to find out. Now we'll write the proof. Okay, I'm not writing to prove and all. To prove is this one only. Find the angle at a point on the major arc and also on the minor arc. Now let's come to the proof. Now in proof what I will write is, you know that we'll start with what is given only. OB is equal to OC is equal to BC. Okay. Therefore, triangle OBC is equilateral. Okay. So therefore, each angle will be equal to angle OBC is equal to angle OCB, OBC, OCB, BOC is equal to angle BOC is equal to how many degrees? 60 degrees, right? Because each angle of an equilateral triangle will be equal. Now, we'll come to the next part here. Just I'll write the arrow over here. Therefore, now, what do you say of angle BOC and BAC now? Angle BOC is equal to 60 degrees. Therefore, angle BAC is half of angle BAC. That is angle subtended by the angle subtended at the center is double the angle at the circumference. Angle subtended at the center is double the angle at the circumference. Is double the angle at the circumference. So angle BAC is equal to half of angle BOC. Angle BAC is half of angle BOC. So angle BAC is half of 60 degrees. Therefore, angle BAC is equal to how many degrees? 30 degrees. Okay. BAC is equal to 30 degrees. Now, when BAC is equal to 30 degrees, now this angle plus the, see, I told you, now this becomes, now we have to find here minor arc also. Now, this is a cyclic quadrilateral, correct? ABMC. Okay. ABMC is a cyclic quadrilateral. Okay. Therefore, angle BAC, that means angle A plus angle M is equal to 180. Why? I just now told you, because they are opposite angles of a cyclic quadrilateral. Opposite angles of a cyclic quadrilateral. So this is how much I got now? 30. This will be how much now? Therefore, angle BMC or M is equal to angle M is equal to 180 minus 30, which is equal to 150 degrees. Now coming to the third question. In triangle PQR, angle PQR is 100 here. PQR are the points. Now this cannot become a cyclic quadrilateral because this point is at the center. It had to touch the circle here, then it would have been a cyclic quadrilateral. But this is not a cyclic quadrilateral. I have to find this OPR, this angle OPR. Now what we do is, now PQR is 100 degrees. Now we can make a construction. Okay, we can make a construction over here, or what you can say is, now this angle is double of this angle. So this angle is double of this here. So if you're not understanding, I told you, see, I told no just now, see, if I draw a circle, if I take like this angle, iske upar means it will be here, it will male here, tala. See how they are, like this, like this. So now if I am taking like this here, this angle, then it will be here. This angle is double of this angle. Okay. So here, this angle is given here. So it can't be this, because this is, see, face to face like this. It can't be like this. It had to be like this. So this angle and this angle are related now. Or if you're not understanding, draw a construction. We'll name it as S. Now this is 100 degrees. Which one? PQR, correct? Angle Q plus angle S is equal to 180. Again I told you, opposite angles of a cyclic quadrilateral. Opposite angles of a cyclic quadrilateral. This is 100 means what will be S? Angle S is equal to how much? 180 minus 100, which is equal to angle S is 80 degrees. So this is 80 here. Now when this is 80, now what can you say of this one now? This is 80 means this will be naturally double. So this will be how much here? 160. Angle POR is double of PSO, double of angle S. Angle POR is equal to 160. But they have asked you this angle, chota sa. So what will take in triangle OPR? All the three angles together must be equal to 180. Now OP is equal to OR. Why? OP is equal to OR because they are radii of the same circle. So we make use of all these concepts. Now when they are radii of the same circle, angle OPR is equal to angle ORP. Okay, because it's isosceles triangle. Okay, now when it becomes an isosceles triangle, now these two angles plus this, so 160 plus angle OPR plus angle ORP equal to 180. That is angle sum property. Okay, so this will take it as x. So 160 plus x is equal to 180. So we'll 160 if you bring here, it becomes 180 minus 60 is equal to 2x. 160. So 180 minus 160 is 20 is equal to 2x. So x is equal to how many degrees? X is equal to 10 degrees. So therefore OPR, angle OPR is equal to how many degrees? 10 degrees.